Dr. Bbosa science, kwano kwa beti science, love ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Somero lya Dative Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A level, we teach sciences only. At O level, we teach arts and sciences. Today, we are going to study chemical bonding. A bond is a force that binds molecules, ions, atoms together in a substance. There are 4 types of bonds. 1, ionic bond or electrovalent bond. 2, covalent bond. 3, metallic bond. 4, van der Waals forces. Ionic bond is an electrostatic force that binds ions together in ionic crystal. For example, in sodium chloride. During the reaction of sodium and chlorine, sodium loses electron to form sodium ion. Sodium minus an electron, you get sodium plus. Chlorine atom gains an electron to form chloride ion. Chlorine atom plus an electron will form chloride ion. The force of attraction between opposite ions, i.e. sodium plus and chloride ion minus, constitutes what we call ionic bond. Usually, an ionic bond is formed between a metal with high electropositivity or low ionization energy and a non-metal with high electronegativity or high electron affinity. Properties of ionic compound: it is made of ions and not molecules or atoms. It is an electrolyte. That is, it conducts electricity in molten or solution form. 3, has high melting point and boiling points. 4, it is soluble in water but insoluble in organic solvents. Ionic compounds are soluble in water but insoluble in organic solvents. Factors affecting strength of ionic compounds. 1, size of cations and anions. Ionic bonds are stronger when the size of the cations are big, while those of the anions are small due to low polarization. For example, sodium chloride is more ionic than lithium chloride. 2, electronegativity or electropositivity differences. The bigger the difference in the above factors, i.e. electronegativity and electropositivity, between the reacting elements, the stronger the ionic bonds. For example, sodium chloride is more ionic than sodium iodide. Covalent bond is a bond formed by sharing electrons between the two atoms of elements or element. A covalent bond may be formed between atoms of the same element or different elements. A normal covalent bond is formed when each atom provides an electron to the shared pair. For example, in hydrochloric acid, hydrogen provides one electron, chlorine provides one electron to form a shared pair of electron or a normal covalent bond. A dative bond is formed when both electrons shared are provided by one atom only. For example, during the formation of ammonium chloride, ammonia with a lone pair of electron donated to hydrogen ion to form a dative bond. In the dative bond, both electrons are provided by the nitrogen atom. A dative bond is shown by an arrow from the donor atom to the recipient atom. Properties of covalent compounds. They consist of discrete molecules. The molecules are bound together by weak forces. That's why they have low melting and boiling points. They are non-electrolytes. They neither conduct electricity in a molten or solution form. They are insoluble in water but soluble in organic solvents. Intermediate bonds between ionic and covalent bonds. Ionic bonds are usually formed between metals and nonmetals, whereas covalent bonds are formed between nonmetals. However, you may find that compounds formed between metals and nonmetals may have properties similar to those of covalent compounds, and those covalent compounds may have properties similar to those of ionic compounds. You may find that compounds which are ionic may be soluble in organic solvents and may have low boiling and melting points. Similarly, you may have compounds which are covalent, formed by sharing electrons, having properties like those of ionic compounds, having relatively high melting points and soluble in water. Ionic compounds showing properties of covalent compounds such as low melting and boiling points, or being soluble in organic solvents, is explained by a terminology called polarization. Polarization is the distortion of the symmetric shape of an ion by approach of a cation. Polarization brings about partialling of electrons in an ionic compound, i.e., when we bring a cation near an ion, the cation will try to attract electrons from an ion to form a partial covalent bond. The partial ionic bond lowers the melting point and boiling point of a compound, and two, it makes an ionic compound soluble in organic solvent. The ability of a cation to polarize an ion or to attract electrons from an ion is called polarizing power. And the ease by which an ion is polarized or an ion donates electron to a cation is called polarizability. Factors affecting the magnitude of polarizing power of a cation: A, the size of the positive charge on the cation. The bigger the positive charge on a cation, the higher the polarizing power. For instance, the order of polarizing power in this cation is that sodium ion has got low polarizing power than magnesium ion, than aluminium ion. For this reason, sodium chloride melting point 801 degrees Celsius is higher than that of aluminium chloride, which is 180 degrees Celsius. Sodium chloride is insoluble in ether. Aluminium chloride is soluble in ether. B. Size of a cation. Smaller cations have higher polarizing power than big cations. For the same reason, sodium chloride is insoluble in ethanol, meaning that sodium chloride is more ionic than lithium, which is soluble in ether. The lithium ion polarizes the chloride ion, forming a partial covalent compound, which is soluble in ether, an organic solvent. C. Electron configuration. Ions with Ns2, Np6, Nd10, such as copper, have high polarizing power than those with Ns2, Np6, such as sodium. Sodium ion and the copper ions have got the same size and the same charge, but copper ion chloride is more covalent than sodium chloride. Factors affecting magnitude of polarizability. A. Size of negative charge. Anions with bigger negative charge are easily polarized than those with low negative charge. B. Size of anion. Small anions are less polarized than bigger anions. For example, aluminium fluoride is ionic, whereas aluminium chloride is not, because the fluoride anion is smaller than the chloride anion. Pagani's rule of covalence. Polarization was first recognized by Pagan. So he set these rules, that these are conditions when possessed by cations and anions in a given molecule make ionic compound partially or fully covalent. Bond polarity. Acquisition of ionic characters such as solubility in water and high melting points in a covalent compound is explained by bond polarity. A polar covalent bond is a bond with positive and negative charges on the atoms that form the bond. For example, hydrogen and fluorine form a covalent bond, there's a partial positive charge on a hydrogen atom and a partial negative charge on a fluorine atom. Bond polarity results from unequal sharing of electrons between atoms that form the bond, because the more electronegative atom pulls the shared pair of electrons towards itself. The more electronegative atom acquires a partial negative charge, the less electronegative atom acquires a partial positive charge. For example, you have already seen that when hydrogen bonds with fluorine, the more electronegative atom will acquire a partial negative charge. Then hydrogen, a less electronegative atom will acquire a partial positive charge. The bigger the electronegative difference between the atoms that form the polar bond, the bigger the bond polarity. The attraction or repulsion of bonding electrons by an atom or group of atoms is called inductive effect. The atom or group of atoms that push electrons to other atom is said to have positive inductive effect, while that pulls electrons is said to have a negative inductive effect. So in this bond, between hydrogen and fluorine has a negative inductive effect, hydrogen has a positive inductive effect. So hydrogen will push electron towards fluorine will pull electrons away from hydrogen. It is the additional forces of attraction resulting from opposite charges on polar molecules that leads to increase in the melting and boiling points of covalent compounds. However, not all compounds with polar bonds are polar. For example, in tetrachloromethane, the bonds between carbon and chlorine are polar, but the tetrachloromethane molecule is non-polar. This is because the molecule is symmetrical and the dipole-dipole moments cancel. In tetrachloromethane, the bonds are polar, but they are symmetrical. So the dipole-dipole moments, when dissolved, will give you zero inductive effect. It is like pulling a person with equal forces on opposite side. That person will not move away from his position, because the force pulling him with the right hand cancels with the force pulling him on the left hand. Similarly, the following symmetrical molecules: beryllium 2 chloride, boron 3 chloride, carbon dioxide, carbon tetrachloride, are non-polar because the dipole-dipole moments in these compounds cancel. So when a compound has got polar bonds but you find that it is non-polar, it is due to symmetry of the molecule. When the molecule is symmetrical, the dipole-dipole moments within its bonds will cancel. Hydrogen bonds. A hydrogen bond is a dipole-dipole attraction between hydrogen attached to an electronegative atom and another electronegative atom. Hydrogen attached to fluorine, which is electronegative atom, and another fluorine atom, which is electronegative. Or hydrogen attached to a fluorine atom and another electronegative atom, which is oxygen. So the dipole-dipole attraction between hydrogen attached to an electronegative atom and another electronegative atom is called a hydrogen bond. Effect of hydrogen bondings. high melting and boiling points. For example, hydrogen fluoride with strong hydrogen bonds is a liquid, i.e. has high boiling point, while hydrogen chloride with weak hydrogen bonds is a gas at room temperature, i.e. it has a low boiling point. Compounds that form hydrogen bonds with water are soluble. For example, ammonia, which is a covalent compound, is very soluble in water. Then high viscosity. For example, vegetable oils form very many hydrogen bonds and they are really viscous when you pour. Another example, comparing the boiling points of hydrides in group 5, you can see that the boiling point increases down the group due to increase in the molecular mass. Definitely that's the right way. As the molecular mass increases, the van der Waals forces also increase. So the boiling point will increase with increase in the molecular mass. However, when you look at the boiling point of ammonia, is higher than that of phosphine because the intermolecular hydrogen bonds formed in ammonia are stronger than the intermolecular hydrogen bonds formed in phosphine. That explains the high melting point of ammonia compared to phosphine. Yet ammonia has got a lower molecular mass compared to that of phosphine. Metallic bonds. In the metallic bonds, each metal atom releases its valence electron in a crystal pool. This free electron is released that cement the positive ions together and constitute a metallic bond. Each atom releases a valence electron into a pool. Then it is these free electrons that cement the positive ions together to constitute a metallic bond. Factors affecting the strength of metallic bonds. 1. Number of electrons contributed to form the metallic bond. The bigger the number of electrons contributed, the stronger the metallic bond formed. For example, metallic bonds in group 2 are stronger than the metallic bonds in group 1, leading to higher melting points in group 2 than in group 1. Because group 2 atoms contribute 2 valence electrons to form metallic bonds, while group 1 elements contribute 1 electron to form the metallic bonds. The second factor is electronegativity. The bigger the electronegativity, the stronger the metallic bonds. For this reason, generally the melting points of metals decrease down the group because down the group electronegativity decreases. For example, in group 2, generally the melting point decreases from beryllium to calcium to strontium to barium. Properties of metallic substances. They conduct heat and electricity in molten and solid form. This is because they have got mobile electrons. They are malleable, can be made into sheets, and ductile, can easily be made into wires. Molecular or van der Waals forces. These are intermolecular forces that occur between non-polar molecules as a result of momentarily induced dipoles in neighboring molecules. These are weak forces whose magnitude increases with molecular mass. This explains the increase in boiling and melting points of group 7 elements. Down the group fluorine and chlorine are gases. Bromine is a liquid, iodine is a solid. So down the group, both melting and boiling point will increase due to increase in the molecular mass and increase in van der Waals forces. Van der Waals forces will increase with increase in the molecular mass. So thank you very much. You can download these notes from digitalteachers.co.uk. Then you check under subject tutorial. You will see chemistry A level. You click on it. It will open for you free notes, among which you have these notes. If you want more videos concerning Dr. Bbosa and digital teachers, find them on YouTube. Search Bbosa Science.